Hello everyone. In this video we are going to see the second application of integration. So we're still in the part of application of integration, where we are going to discuss on how to find a volume by using a cross-section method. So the idea of finding a volume of solid here is basically to use the cross section of the area, and we are going to rotate it based on axis of x or y, depends. So basically right here we are going to define a volume, which is we are going to find a volume of it, and we are going to generate a solid. So the solid is either a circle, one circle, or we get something like a ring. So if we get a solid that we call as a circle here, we are going to use what we call as this method. And if we get the something a circle something like this, we got two circles of it, so we are going to use what we call as a washer method. Okay, later in the next video, basically we are going to see what is the difference between this and washer method. I'm going to explain it by using a few examples. But here, the general way how to calculate it by using the slicing of a parallel plane, where we are going to determine the volume of solid, which is can be integrated by using a cross-section area, which is AX. So basically we still use AX. So A here basically refer to the value of your area, or the function of your area with respect to X or Y. So it's not necessarily AX, it can be sometimes AY, which is it depends on how you do the slicing part. I'm going to also explain it by using example of this. And we are going to apply all these four steps, which is the first part is will be easier for us to use this formula or try to construct this formula by sketching a graph of it, graph of a equation, and then we are going to translate it into the integrals here. So the first step, sketch graph. Second, we are going to find a formula of your area. Then we are going to also find a limit. The limit here represent the value of your upper value and also lower value of your integrals. And then we are going to deal with the integral techniques to find the volume. Alright, so without wasting any time, let's try to see the example. Okay, before we start with the example one, basically we need to know a bit more on the part of this method. Previously I already showed you that in order for us to use this method, basically we are going to get a solid, or basically we are going to generate a solid which is can be represented by a circle. So here, in order for us to obtain a circle, so the question here is how to obtain a circle, how to get the solid like this. So here, in order for us to deal with that, we are going to find the graph with area. So basically we are going to deal with a graph and we are going to find the area of it. So let's say here we got x and y. Let's say we have something like this. So this is the area. So we are going to generate the solid by rotating the area either by using the y-axis or x-axis. It depends on the question. So in our question, basically I will mention the rotation axis, and we are going to do the slicing part. We also must also put the slicing method. So the slicing method here depends with the rotation axis. So if your rotation axis is y-axis, if your rotation axis is something like this, we are going to do the method of slicing perpendicular, which means our method of slicing should be on the y-axis. So your method of slicing is something like this on the x-axis. Method of slicing should be horizontal. Method of slicing. But if your rotation axis is on the x-axis, see here is x is y, so your method of slicing should lies on the vertical one. So it will be a vertical slicing. If your rotation is y-axis, so we are going to use horizontal slicing. Okay, so let us apply it in our example. So let us move into the example A here. Okay, let's say here the question say that you already have the region. So basically the region here represent the value of your area between a curve. So the curve here can be represented by the function. So now we have a function of y equals to square root of x, and the limit of your function here is, or a limit of your area here is between 0 and 4 for the domain of x and the x-axis. So we have two constraints here, which is the domain of 0 and 4 and x-axis, and it's revolve about the x-axis, which is revolve of x-axis here represent the rotation axis. To generate a solid, so here we are going to see whether our solid here is a circle or we are going to have something like a ring there. So if we are using a circle, so basically we are going to call it as a this method. If we get a ring, something like a ring there, basically we are going to deal with a washer. But in our example here, most probably we are going to get a disc. So let me erase for that part. So the question here, we are going to find the volume. Okay, as we already know, in order for us to find a volume, so volume can be obtained by using the formula of integrating the value from a to b, which is your lower limit to the upper limit of your function ax with respect to dx, or it can be v equals to cd, which is we have our own limit there, but now is in terms of y dx dy. So it depends on how you deal with the slicing method. I will show you when we are going to use the ax and when we are going to use ay. Okay, now let us start with the first step, which is we are going to sketch the graph of our function there. So here we see here we have x and y axis. This is your y and this is your x axis, and of course you are going to have your origin here. So y equals the square root of x. As we already know in the mathematics 1, we are going to have a basic graph something like this. Y equals to the square root of x. And the value of our limit is between 0 and 4. So 0, maybe we can put it somewhere here, the value of 4. This is our limit there. And the x-axis. So basically it refers to all these x-axis. So you can see that the area that mentioned is on this part. Right? So once we already get the area of it, we are going to rotate the part that we have here. So in order to do that, let us explain it in a next video, I think. So we are going to use the same example, and I will put it in a whiteboard to see whether we can see the difference of drawing here. Okay, so see you in the next video.